Hi friends, welcome back. Hearty welcome to you. We are going through geometry as part of 10th class syllabus. We have gone through the similar triangles. Now we want to prove the Pythagoras theorem using the similar triangles. We have seen in earlier classes how to prove Pythagoras theorem in different ways. Now in this particular session or in this 10th class syllabus, 10th grade, we will be looking at how to do that with respect to the similar triangles. Okay. Now there is a theorem. Using this theorem, leveraging this theorem, we should be able to prove Pythagoras. So let's try to understand the theorem. The theorem says, if a perpendicular is drawn from the vertex of the right angle of the right triangle to the hypotenuse, then the triangles on both sides of the perpendicular are similar to the whole triangle and to each other. Okay. So you can see that you have a right angle triangle ABC and you have drawn a perpendicular from the vertex of the right angle to the hypotenuse. Then the triangles on the both the sides of the perpendicular are similar to the whole triangle ABC, and also they are similar with each other. Let's try to understand this. Okay, for that what I will do is I will take this angle as theta. If I take this angle as theta, then you know this is 90. That means this part will become 90 minus theta. If this is 90 minus theta, and I will keep them in double, okay, then this will become theta, right? And if this is theta, this is 90, you have this one will be nothing but equal to 90 minus theta again. Can you see that? Now why we are doing that? Because we want to prove that all these triangles are similar to each other. There are so many ways of doing it. You can just take the triangles one by one and say that this is the common angle and you also have 90 degrees. But what I prefer is just put down all the sides and show that all the angles are equal. That means all the triangles are similar to each other. Because by AA similarity, we can prove that if two corresponding angles of the similar triangles are equal, then the triangles are similar to each other and then their sides will be in proportion. That is what we will use to prove the Pythagoras theorem. So I will go ahead, what I will do, I will put down the triangle names. First I will take ABC triangle, that's my big triangle. Then I will go for ABD, that's another triangle which is formed after the perpendicular is drawn. Another triangle is BDC. Okay, right. This is the name of the triangle. Okay, now I'll go here, I'll give angle. We will give angles here. What are the angles we have? Theta, 90, 90 minus theta, right? Okay, let us say theta, 90, 90 minus theta. Let us see. If I take triangle ABC, if I take triangle ABC, where I have theta? At C. C is theta, angle C is theta, and 90 degrees I have at B. So angle B is 90 degrees in ABC and 90 minus theta is at A. If I take ABD, where I have theta at B and I have 90 degrees at D and I have 90 minus theta at A. So you can see in these two triangles, angle A is common, and you can also see that both of them are equal to 90 degrees. So you can say they are similar to each other. Okay. Next BDC. If I go to BDC, where I have theta, theta is at C, and 90 degrees is at D, and 90 minus theta is at B. Pretty straightforward, right? Okay. Now what we have done, we have just taken one angle as theta. Based on that, we have found remaining all angles. Now we have seen that all these triangles have theta, 90 degrees and 90 minus theta at different vertices. That means all these triangles are similar to each other. Okay. Now how to prove that is nothing but, since you can take these two triangles ABC and ABD. If you take ABC and ABD, if you take ABC and ABD, angle A is 90 minus theta is common, remaining 2 is 90 degrees. So by AA similarity, ABC is similar to ABD. If you take ABC and BDC, you can see that C is common, theta is common in both of them, and you know angle B, angle D is 90 degrees. So that way also you can say ABC and BDC are similar to each other. Then by that you know that ABD and BDC are also similar to each other. Okay. Now let's leverage this, how to find out the Pythagoras theorem, how to prove the Pythagoras theorem. For that, what I will do, what we have to prove as part of Pythagoras theorem, let's write it here. What we have to prove is AC square equal to AB square plus BC square. That is what I have to prove. Okay. Now that means when I go for similarity, I have to make sure that I will get AB square and BC square, then I can add them. Okay. What I will do first is, if I look at ABC and ABD, if I look at ABC and ABD, what we know about similarity? We know that if two triangles are similar, then their corresponding angles are same, and the sides, corresponding sides are in proportion, or they are in the same ratio. Now what will be the corresponding sides? I can easily find out because I have this table with me. Now what I will take first is, I will take triangle ABC, comma, triangle ABD. If I take triangle ABC, triangle ABD, now if I go for 90 minus theta to 90, which side it is? AB. So it's, I can say AB divided by, in ABD where I am going from excuse me, 90 minus theta to 90, that is nothing but equal to AD. That's equal to, now if I check for in ABC comma ABD, where I am going from 90 minus theta to theta, that's nothing but AC divided by AB. What I am trying to do now is, I need to get AB square, right? So I am looking here where I have AB in these two triangles. I have AB here, I have AB here. When similar triangles, the sides should be in, corresponding sides should be in proportion. So I can say AB divided by AD is nothing but equal to AC divided by AB. That way I can get AB square. Now I got part of it, right? Similarly, what I can do, I can go to next to two triangles, that is nothing but triangle ABC, and I will compare triangle BDC. Now what is our focus now? I want to get BC square. That means I have to look for where BC is there. I can see BC here in ABC and BDC. That is what we are interested now. These two we are interested. So we know that in both of them angle theta is C at C. So I can say BC by DC, I can say BC divided by DC is nothing but equal to, BC divided by DC is nothing but equal to AC divided by BC. I hope you agree with me on that. Simply what we are trying to do, we are trying to find out the corresponding sides. How to find out the corresponding sides? I can find out the corresponding sides if I know the angle. Now this is nothing but equal to, will you agree that this is nothing but equal to AB square equal to AC into AD? and this is nothing but equal to BC square equal to AC into DC. Now what we have to prove is AB square plus BC square. So let's add these two. This is 1 and this is 2. If I add them, what happens? Let us see. If I add 1 plus 2, 1 plus 2 will give me AB square plus BC square equal to, I can take AC common, so I can say AC into AD plus DC, that is nothing but equal to AC in AD plus DC is nothing but equal to AC. So I can say it is nothing but equal to AC square. So we have proven Pythagoras that AB square plus BC square equal to AC square, or the sum of the remaining two sides of the right angle triangle is equal to the sum, actually the sum of the squares of the two sides of a right angle triangle other than the hypotenuse is equal to the square of the hypotenuse, or you can say the square of hypotenuse is equal to sum of squares of the remaining two sides, or AC square is equal to AB square plus BC square. That is what we have proven, and we have proven it using similarity. Let me just summarize this, what we have done. So we have a theorem in similarity using right angle triangles, where we say if you have a right angle triangle, you drop a perpendicular from the vertex where you are making right angle to the hypotenuse, then the perpendicular whatever you have drawn to the both sides of it, whatever the triangles you have, they are similar to the whole triangle. That's nothing but big one ABC here, and they are also similar to each other. How you want to see? Let us start with one arbitrary angle as theta. If I start with angle theta, I have perpendicular, so I have 90 degrees in every triangle, and I have common angles in all the triangles. So you can see them, all of them have same angles, theta, 90 degrees and 90 minus theta. And which side is corresponding to which side in the triangle, you can easily find out once you have placed them according to the angles, because we know that in similar triangles the corresponding angles should be same and the corresponding sides should be in proportion. Now I have taken ABC and ABD. Now our idea is to prove Pythagoras. So we want to say AC square equal to AB square plus BC square. So I have to find out AB square. So for that, what I have done, I have taken ABC, ABD. I know where I have AB. So AB by AD is nothing but AC by AB. Similarly, if I take ABC and BDC, I want BC now. So I can say BC by DC is nothing but equal to AC by BC. So both of them will give me AB square equal to AC into AD and BC square equal to AC into DC. If you add them both together, it's nothing but equal to AB square plus BC square equal to AC square, which is nothing but Pythagoras theorem. So in the next session, we will solve some examples based on Pythagoras theorem and similar triangles. Thanks for visiting. See you in the next session. Bye for now.